Okay, guys, question number one is what we will be looking at. So, what I'm going to do very quickly is just to read through the given statement and at the same time look at that given diagram. And lastly, we're going to look at the questions. I'm not going to be answering the questions, but what I'm going to be doing is just to guide you in terms of how you answer the question. So the statement reads as follows. In the diagram below, P being a point having the coordinates 3 and 0, there is P. Q having the coordinates negative 3 and 2, there is Q. R, where is R? R is there. And S having the coordinates 2 and negative 3 are 4 points in the Cartesian plane. Makes sense. You just need to be aware that you've got a point being P, which lies on the x-axis on the positive side. That is why you're having positive 3 and 0. 0 because it lies on the x-axis. So on the x-axis, obviously, you can see that y is 0. You also have a point Q which lies in the second quadrant, R in the third, S in the fourth. Very, very much important, ladies and gentlemen, on that one. So I think very quickly, let's try to have a look at the questions and see how far we can go. I think the statement, it is represented diagrammatically. So this is what I'm going to do. Let's roll down and then we look at the questions. So let's see. The first question says calculate the gradient of PQ. Where is P? Let me quickly do that. There is P and there is Q. It has to be an easy question considering that it is allocated 2 marks. You just need to pull out the gradient formula and you substitute. Remember, analytical geometry, it's a game of two things. We know that the gradient formula says change in y over change in x. So from these 2 points, you will know what is your x value, what is your y value. But most importantly, this is how I used to do it. Sometimes one would ask and say, which ones are going to be the y2, y1, x2, x1. So between letter P and Q, which letter comes first? The letter that comes first, then you have your x1 and your y1. The letter that comes second is your x2, y2. So it's easier when you work it out that way because you remain consistent and you won't get confused when you continue with some other questions. So that's how you work out that question. So let's quickly jump on to 1.2, which says determine the equation of line RS. Where is R? Where is S? There is R and there is S. So now they are saying determine the equation of line RS, which is parallel to line PQ. Very, very much important. Don't get confused. They are talking about a line of RS. So from R to S, this is the line that you need to determine. And they are saying that line is parallel to that line. And we know something about parallel lines. So that means the gradient of line PQ is equals to the gradient of line RS. Let's say as an example, we got -2 as the gradient of a PQ. So automatically the gradient of RS is also -2. So already you have y, which is equals to -2 being the gradient x plus C. All that you need is just 1 point along RS or on RS, which is point S. Then you can just say at point S, having the coordinates 2 and -3. Remember, guys, this is just an example. You must have calculated it there and you need to get the correct value. So what you now do is to substitute your y value being -3, you substitute it there, you substitute your x value there in order for you to calculate the c value. Once you calculated the c value, let's say your c is equals to -100. Obviously it won't be a negative value because it cuts the y-axis on the positive side. Maybe let's be realistic and say positive 100, just as an example. So that means the equation of that line is going to be y, which is equals to -2x plus 100. That's how you score yourself full marks for that question. So I think I've given you enough information for you to work it out. So I'm just going to remove all of that, and then from there we jump on to the next question. So just make sure, honorable members, that you do those calculations and you know the exact values. In that way, you will be able to find sensible answers, which will enable you to continue and move on to the next question. So let's see. The next question, 1.3, it says determine the equation of a line that is perpendicular to line RS and passes through the point 0 and -2. This question is allocated 2 marks. Might be a bit tricky, but most importantly, they are saying you need to determine the equation of a line. And that line, it is perpendicular to RS. So this is line RS from R to S. This is a line. And now they're talking about a line which is perpendicular, obviously forming a 90 degrees. But most importantly, that line is passing through 0 and -2. So by estimation, I can say 0 and -2 at somewhere at that point where x is 0 and y is on the negative side and it's -2. So to construct a line which could possibly be a line, no, it doesn't look right. I will need to try and redraw that. You will understand why I'm saying that. Maybe it could be, I think I've just erased that line. So let me try to find a different color so that it makes sense. So I'm actually trying to construct a line which is almost perpendicular. It seems like I won't get it correct, but it's fine. So that means that -2 possibly it's somewhere there. Remember, this is just an estimation, just so that you understand. So this point is actually 0 and -2. So you might need to temporarily forget about that point. Let me just remove it. Yes. So the reason why I had to draw that is so that you can notice what we are talking about. You say that line, it is perpendicular to that, meaning it forms a 90 degree there. What do we know about perpendicular lines? We do know very well that when you multiply the gradient of this line and the gradient of that line, it has to give you -1. So that means if the gradient of line 1, when multiplied by the gradient of line 2, it gives -1. Do we know the gradient of RS? Yes, we do. If you remember, I estimated it to be -2. So let's maybe say it's -2. And then the gradient of the second line, it's unknown, but we can calculate it using this formula. So that means the gradient of that line which is passing through that point of 0 and negative 2. It is therefore going to be, you divide both sides by negative 2. So that means you are having negative 1 divided by negative 2, which is positive half. So that means already you know the gradient of this new line. So this is how your equation looks like. So that means you're having positive a half x plus c. Now you need a point, which is that point that they gave you, because they knew you are going to need that point to calculate or determine an equation. So can you see, you now take that y value, you plug it there, you take that, you plug it there, so that you can calculate the c value. So in this case, let's assume the c value to be maybe let's say, we might not even need to assume. I just noticed something. It is going to be negative 2. Why? Because already c refers to the y-intercept, and we already know that. Which explains why this question, it's actually allocated less marks. So that means already, even if you do calculate, you will end up having something similar to this. Y is equals to whatever the gradient that you calculated with the correct values. Your y value, it will end up being, your c value, it will end up being negative 2. You can either work it out just like I've explained there, or you can straight away notice that actually we are given the y-intercept, which is negative 2. Someone might be wondering, in which case are we going to know that we need to do an observation or take it from the given information? So if a point lies inside a quadrant, that means you will need to definitely calculate, because you are trying to calculate the y-intercept. In this case, the y-intercept is given. How do you know is the y-intercept? It is because of that being 0 there. That's how you know it is the y-intercept. But if it wasn't 0 but just any other number, then you know it falls inside the quadrant. So I think I've given you enough information on that one. So I might need to just quickly remove all of these and we jump on to the next questions. Ladies and gentlemen, just make sure that at all the times you pay full attention, and most importantly, do not start by solving these problems without you watching a lesson where I do an introduction, because it explains all that you need to be aware of regarding all of this. So just make sure that you watch an introduction, and then afterwards you can try this question. So let's see. The last question being a 1.4. Calculate the length of PS. Leave your answer in SAT form. The length of PS. Examiner won't say the distance, but it's in most cases where they say the length. You just need to remember that when it comes to the length, you can use the distance formula. Mathematically, length and distance refers to one and the same thing. I'm pretty much sure that you do know the formula. It's either you are given on your formula sheet, but just make sure that you know it by heart. You know what's inside. X2 minus X1, Y2 minus Y1. Most importantly, the distance of PS. Where is P? Where is S? There is P and there is S. Meaning your final answer will be in a form of a square root. Do not write it as a decimal, but leave it as a square root. Very, very much important, ladies and gentlemen, on that one. So I think you now have an idea of how to work out that question. So, ladies and gentlemen, I do thank you very much for joining. Let me make sure that I sign out. So guys, my name is Desmond and I'm out.